Hello everyone, this is Mrs. Chen. Nice to see you today. And today we're going to learn about multiplication by 10, 100, and 1000. And today's objectives are I can interpret and represent patterns when multiplying by 10, 100, and 1000 in arrays and numerically. I can multiply multiples of 10, 100, and 1000 by single digits recognizing patterns. And I can multiply two-digit multiples of 10 by two-digit multiples of 10 with the aerial model. And now you will need a piece of blank paper and a pencil, a whiteboard and a marker. I will give you 1 minute to go get those materials. So with our first objective, interpret and represent patterns when multiplying by 10, 100, and 1000 in arrays and numerically. So we are going to draw place value disk to represent products when multiplying by one-digit and two-digit numbers, then decomposing multiples of 10 before multiplying. So how many do we see right here? So we have 3 ones, isn't it? And how many groups of 3 ones do you see? Just one group, right? So we can write as 3 ones times 1. And suppose I wanted to multiply 3 ones by 10 instead. How would I do that? We can just move each disk over to the tens place and get 3 tens. So like, let's group this and move to the tens place times 10. And that gives us this. So we can also write this down as 3 ones times 10. Okay. And what if I wanted to multiply that by 10? So let's do the same thing. Move them one more place into the hundreds and get 3 hundreds. So we can write this as 3 ones times 10 times 10. And look at my equations. I started with 3 ones. What did I multiply 3 ones by to get 3 hundreds? We multiply by 10, then multiply by 10 again. That's 100. And I can group the 10 times 10. So this is really 3 times 10 times 10. That's just 3 times 100. So how can we solve 3 times 1000? So 3 times 1000 by showing 3 ones times 10 to get 3 tens, then times 1 again to get 300s, and times 10 again to show 3000. So like this, same as what we were doing, like this. So I draw an arrow representing times 1000 from 3 ones to the 1000 column. And what is 3 times 10 times 10 times 10? That is 3000. Okay. Oops. Okay. And let's see this one right here. 15 times 10. So let's present 15 in the place value chart first. So we have 1 tenth and 5 ones. So how are we gonna present this? 15 times 10. same as what we did before. So let's group this and move to the tens place by times 10. And also group this one, move to the hundred place by times 10. Because we need to show times 10 for each of our units. So for this one, we have 5 right here and 1 right here. So what is 10 times 10? That is 100. And what is 5 ones times 10? 5 tens. And what is 15 times 10 equals? That is 100 plus 50, which is 150. Okay, and let's see this one, 4 times 20. So just like 3 times 100 can be expressed as 3 times 10 times 10, there are different ways to show 4 times 20 to help us multiply. So what is another way that I could express 4 times 20? So there are some ways for us. 4 times 2 tens, or 4 times 2 times 10, or 8 times 10. So let's select one that is most helpful for us. So I will choose 4 times 2 tenths because I know 4 times 2. Because 4 times 2 is 8. And 8 tenths, I know what 8 tenths is. That is 80. So let's put down the place value chart. So we have 1, 2, 3, 4, 5, 6, 7, 8. Because we know 4 times 2, that is 8. And we move to tens by 10. That gives us 1, 2, 3, 4, 5, 6, 7, 8. 8, and that is 20. And that will be the same thing, put down the place value chart for this too as well. Okay, and now it's your turn. I will give you 2 minutes to complete this practice problem. Then we will come back together to go over the answers. Okay, and let's go over the answers right now. So the first one is for us asking us draw place value disk and arrows to represent each product. So for this one, we have 36 times 1000. So let's draw 36 first. So we have 3 tens and 6 ones. And remember what we said, we have to make sure each of our units are multiplied by 1000. So we're moving this by 1000, which is 1, 2, 3, 3 tenths. So let's move once to here, and second, and third time. And for this one, let's move this. Let me use another color. One time, second time, and third time. This section will be 10,000. Okay, so we have right here, we have 3. And right here we have 1, 2, 3, 4, 5, 6. And what is 6 times 1000 times 1000? That is 6,000. And what is 3 times what is 30 actually right here? 30 times 1000. That is 30,000. Okay, and what is 36 times 1,000? That is 30,000 plus 6,000, which is 36,000. Okay, and the second question is decompose each multiple of 10, 100, or 1,000 before multiplying. So let's look at the first one. 2 times 80 equals 2 times 8 times 10. Since we already have 2 right here, 8, and we're missing 10. And 2 times 8 equals 16. And 16 times what will be equal to 2 times 80? That will be 10. Let's directly put that down. And what's 16 times 10? That is 160. Okay, and let's look at our second one. 7 times 6,000. We can write as 7 times 6 and times 1,000, right? Okay, and what is 7 times 6? That is 42. And times 1,000. And what's 42 times 1,000? That is 42,000. Okay, and with our second objective, multiply multiples of 10, 100, and 1,000 by single digits recognizing patterns. So we're going to use place value disk to represent multiplication patterns and numerically represent single digit numbers times a multiple of 10 and solve a word problem by finding the sum of 2 different products of a single digit number by a 2 and 3 digit multiple of 10. Okay, so let's see what we have right here. So we have 2 ones times 4, 2 tens times 4, 2 hundreds times 4, 2 thousands times 4. So let's first show 2 ones times 4 on our value chart. So we have 2 ones, a group, but we have group of 4. So we have 3 more groups. 3 and 4. We have 4 groups. So this represents 2 ones times 4. And then let me use another color to represent our 2 tens times 4. So we have 2 tens and with 4 groups. 1 group, second one, third one, and fourth one. Okay. And so what is 2 times 4 is? So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 ones. And what is 2 times 4? That is 1, 2, 3, 4, 5, 6, 7, 8. Also 8 tens. Also equals to 80. Okay. And let's represent 200 times 4. Let me use another color. Okay, so we have 200s and in 4 groups. 1, 2, 3, 4. And what is 200 times 4? That is 800s. And also equals to 800. And what is 2,000 times 4? It will look the same again. So like this. Let me use another color. 1, 2, 3, 4, 6, 7, 8. Like this again in thousand place. The answer will be 8,000 because we multiplied 2 times 4 in the thousands column. Okay. So let's look at this one. So we have 8 times 2, 8 times 20, 8 times 200, and 8 times 2000. So what patterns do you notice? So for me, I notice all of the problems have 8 as the factor. So they all have 8. 8, 8, 8. And the units are in order of the place value chart, like smaller to largest. So even they're not in the place value chart, but they're from smallest to the largest. The units we multiply is the same unit we get in our answer, like 8 times 2 tens equals 16 tens, and 8 times 200 is 1600. So what is 8 times 2? That is 16. 8 times 20, 16 tens. And 8 times 200, 1600. 8 times 2000, 16 thousands. Okay, and what happens if we change the unit from 8 times 200 to 800 times 2? Does the answer change? Okay, let's see. So we have 8 times 200. Let me clear this one. So we have 8 groups of 200s. And we have one group, 2, 3, 4, 5, 6, 7, and 8. So how many do we have? We have 1600s, which is 1600. And let's see, let me use another color. Or let's erase this one first. And what about 800s times 2? So we have 800s. Oh, I have one more. Okay, so we have one group. And we have 2 groups. So we have 2 groups of 800s. And how many do we have? We have 1600s. And also equals to 1600. So both statements are equivalent. Okay, so let's look at this word problem. So Francisco played a video game and earned 60 points for each coin he collected. He collected 7 coins. How many points did he earn for the coins that he collected? So first we know he collected 7 coins. So let's try to make a like a bar for the coins he already collected. So we have 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so we already have 6. We have 7 for 7 coins, and it says 60 points for every coin he collected. So each little bar that represent 60 points. And what's our question? How many points did he earn for coins that he collected? So we're looking for the total points he earned. So let me name it letter A. So letter A is what we're looking for. So we have 7, and each one, each coin that is 60. So we're using 7 times 60, so we can get letter A. So we can break this to 7 times 6 times 10. And what is 7 times 6? That is 42, and times 10. And what is 42 times 10? That is 420. So this is our answer. 420 points he earned for the coins that he collected. So this is the answer for this word problem. And now it is your turn. I will give you 2 minutes to complete this practice problem, and then we will come back together to go over the answers. Okay, so let's look at our first one. Draw a place value disk to represent the value of the following expressions. So we have 4 times 2000 equals to what times what is. So we can write down 4 times 2000. So which means we have 4 groups of 2000. So let's put this on the place value chart. So we have 2000, but we have 4 groups. 2 groups, third and fourth. Okay, and how many do we have right now? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 7. Oh, sorry, we have 8,000. So we can write as 4 times 2000 is 8,000, or we can write 8,000 like this. Okay, and let's look at our second question. At the school cafeteria, each student who orders lunch gets 6 chicken nuggets. The cafeteria staff prepare enough for 300 kids. How many chicken nuggets does the cafeteria staff prepare altogether? So we already know that we have 300 kids, and each student gets 6 chicken nuggets. Okay, so right now I will draw a bar that represents 300 kids. And 300, that is too many, so I will just draw like this to represent 300. So 300 kids. And each bar that represents 6 chicken nuggets. Okay, so our question is, how many chicken nuggets does the cafeteria staff prepare altogether? So we have to find the total amount of chicken nuggets does the cafeteria staff prepared. So I will give it letter A. So letter A is what we're looking for. So our equation will be, let me use another color. 300 times 6 equals to A. So we can break this to 3 times 10 times 10 times 6. And what is 3 times 6? That is 18. And let me erase this first. Okay, and times 10 times 10. So what is 10 times 10? That is 100. And what is 18 times 100? That is 1800, which is 1,800. So this is the total amount of chicken nuggets does the cafeteria staff prepare it all together. Okay, and with our third objective, multiply two-digit multiples of 10 by two-digit multiples of 10 with the arrow model. So we're going to use the place value chart to multiply a two-digit multiple of 10 by a two-digit multiple of 10, and create an area model to represent the multiplication of a two-digit multiple of 10 by a two-digit multiple of 10, and use an error model and place value chart to represent the multiplication of a two-digit multiples of 10 by a two-digit multiple of 10. So let's look at this one, 30 times 20. So we are multiplying a two-digit number by another two-digit number. So what are some other ways we could express 30 times 20? So we can express like this, 3 tens times 2 tens, or 10 times 20 times 3, or 10 times 30 times 2, right? Or 2 times 30 times 10, right? And or 3 times 20 times 10. Okay. So let's use 10 times 20 times 3. Let's use this one in a place value chart to help us solve 30 times 20. So let me erase the rest of them. Okay, so what is 2 times 10? 2 tens times 10, sorry. So let's draw 2 tens first, and then circle like we always do times 10. So that will give us 2, which is 200. So 2 tens times 10, that equals to 200. So then what is 200 times 3? This also means we have 3 groups of 200. So let's draw another 2 groups right here. So this represents 200 times 3. So how many we have? We have 6 hundreds, which is, we can write as this 600. Okay, and let's use 10 times 30 times 2 to put down the place value chart to see if we can use this expression to solve 30 times 20. So we have, so what? Let's try to solve 10 times 30 first. So we have 30, 3 tens, and times 10. Move to another disk, and we have 2 groups. So how many do we have right here? 6. And what unit are we? We're hundreds. So did we get the same answer? Yes, we got 600 again. So then we know when we multiply a two-digit numbers by another two-digit number, there are many equivalent ways to express it as a product. Decomposing our multiplication problem into more units can help us solve. Okay, so right now we have 40 times 20. So let's model 40 times 20 as an area. So what is 40 times 20 is? So we can write as 4/10 times 20, right? Or we can directly write down 80/10 or 800. So what is 20 in unit form? That will be 2/10. And what is 4/10 times 2/10? So I know 4 times 2 is 8. And that leaves both tens. 10/10. It's like saying 4 times 2/10 is 10/10. So we can break this 40 times 20 because we know what is 4 times 2. And that leaves us another 10 times 10. So 4 times 2 is 8. And 10 times 10, that is 100. So our answer is 800. So let's prove that we can multiply the units. So draw a 40 by 20 rectangle on your personal whiteboard or paper and partition the horizontal side into 2/10 and then vertical side into 4/10. Label each side what is the area of one square. So each one represents 10. So this area represents 2/10 and this side represents 4/10. So we have 4/10 times 2/10 equals to 800. Okay, and it's your turn. I will give you 2 minutes to complete this practice problem. Then we will come back together to go over the answers. Okay, so our first question is draw an error model to represent 20 times 30. So let's try to make error model for 20 times 30. So let's draw 20 times 30 rectangle right here. So this side, each side represents 10. So this represents 20. And this each side represents 10, and this side is 30. So what is the area of one square? That is 10 times 10 for 100, right? And we have 100, 100, 100, 100, 100. And how many do we have? 1, 2, 3, 4, 5, 6. We have 600. Okay. And our second problem, to print a comic book, 50 pieces of paper are needed. How many pieces of paper are needed to print 40 comic books? Okay, same. Let's use the error model again. So this side, let me draw 1, 2, 3, 4, 5. And each side that represents 10. And this gives me, let me erase the top one. The top one is 50. And the side, each side is 10. And this side represents 40. And what is one single small square? So that is 100, 100, 100. So how many 100 do we have? So we have all hundreds right here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 hundreds. And what is the total? That is 2,000. So it needs 2,000 pieces of paper to print 40 comic books. Okay, and so that's all for today. So today we learned about interpret and represent patterns when multiplying by 10, hundreds, and 1,000 in arrays and numerically. Multiply multiples of 10, 100, 100, 1,000 by single digit recognizing patterns, and multiply two-digit multiples of 10 by two-digit multiples of 10 with that area model. And here are some resources for you to practice at home. And I will put both of them on the learning guide as well. So the first one, both of them are from Khan Academy. So this one is for you to understand multiplying by a multiple of 10, 100, and 1,000. So for example, right here. So we have 50 times 4. And what is, which number should I put inside right here, inside this box to make the first step same as 50 times 4. That is 10 times 5 times 4, right? And for the second step, what is 10 times which number will equal to our first step, which is 5 times 4, which give us 20. So 10 times 20. And the third step is what is 10 times 20? So 10 times 20, that is 200. Okay, this is just one example. And the second one is multiply two-digit number with area models. So it will give you some area models right here and asking you to solve each area's number. So what is 30 times 50 for area A? So that will be 30 times 50, that is 1,500. And for B, what is 30? So this shares the same side with area A. So this is 30 as well. So 30 times 7. What is 30 times 7 to get area B? So that is 210. Okay, and this is really helpful, I think. And yeah, that's all for today, and I will see you next time. Bye.